All right, so I want to talk about diodes. It seems like many of you on the homework may have not properly understood the diode question, which may reflect that you don't actually know how a diode works. So let's draw a circuit with a diode. So here's our voltage supply. And what we're going to do is we're going to draw a resistor and then a diode with the diode symbol. And then maybe we'll have a little lightning bolt here to show us that this is a LED. Okay, so the way that a diode works to first order is that it has a voltage current diagram that looks like this. So if we were to draw on this axis, this is going to be current, and this is going to be voltage. The way that a diode works is that up until a certain voltage, no current flows, and then past that voltage, infinite current flows. And so we would call this the V the threshold voltage or the on voltage of the diode. So in reality, the curve doesn't actually look like this, right? The curve actually looks something more, more like this. And if you guys haven't actually studied that yet, I guess you get it in 305, apparently. I thought you already had it by now, but that is what it is. So the way that a diode behaves in a circuit is that if it's off, so if the voltage here, so this is, we'll call that V, is less than V thresh, then again to 0th order or first order, this is effectively off. No current is flowing, right? If V is greater than V thresh, then it appears that infinite current can flow or current flows through it. But there's always a voltage drop of that V thresh over this diode while current is flowing. So when current is flowing, there's this V thresh across this diode. And so what that means is that if you're trying to understand how much current will flow, and you know the value of this resistance R, and you know the value of this voltage VD, then now you can draw out what you can calculate what the voltage here is, right? So if you know I, then you know that V diode equals VD minus I times R, right? And if it's on, we said to first order that this equals V thresh. And so that is how you should calculate the value of R so that you limit your I. So you can rewrite this formula, IR equals VD minus V thresh, or R equals this divided by our current I. Okay, I think many of you didn't include this factor, and that could be a fairly significant factor if the VCC for the MSP 430 is 3 volts or 3.3 volts, and V thresh is 1.5 volts. Then that's almost 50% difference. Okay. So that's the first point about diodes. Now here's the next point about diodes. So here is a tape of, these are, I believe, red LEDs. We're going to find out in a second, that are the size 1206, which is the same size that you're going to use for your the lab where you're going to be soldering. And the second thing that I want to teach you about diodes today is how do you figure out when you look at this diode, which direction it faces. So something important about this diagram is that current can flow in this direction if the voltage is high enough, but current can't flow in this direction, right? So current doesn't flow in that direction. That's sort of the standard model of the diode. If we go back to our curve and we actually extend it in this direction, then there's somewhere over here, there's a breakdown voltage where current will flow again. But we usually ignore those. And in fact, a lot of times we'll use diodes as a way to protect our circuit against those sorts of things. All right, so here's our surface mount LED. And let me see if I can get this magnifying glass to focus a little bit nicer on that. Let's see. Focus. Focus. Let's see. There we go. Well, what's that? That's definitely not better. All right. That's about the best we're going to do. So with this USB magnifying glass, you can see the two traces that are leading to the actual silicon that is the LED in this case. So the silicon is right there in the middle, and there's a ground trace it's leading to that's underneath it, and then coming off of this side, there's a little wire bond that we can't see at this magnification. That is the actual, that's the other side of the diode's terminal, either the cathode or the anode. So cathode, anode refer to the direction that current is flowing in a diode. And I can never remember exactly which one they are. So let's just draw them here on the diagram in order to help us remember. So the cathode is the direction that the current is flowing into, and the anode is the direction that the current is flowing out of. If that makes sense. So the current is flowing from the anode to the cathode. And a lot of times you might see this marked as plus, this marked as minus, to just help you remember, the direction, the current flows from plus to minus. Also, the direction of the arrow is the obvious way that tells you. So for your lab, you're going to be placing a bunch of LEDs onto this PCB, and you can see the little diagram here, and there's a little arrow that's pointing the direction that current is supposed to flow from the anode to the cathode, right? And in the case of this particular circuit, the current is flowing out of one set of pins and into another set of pins. And that's something cool that you can do with diodes, right? So in this case, what we have is we have our voltage limiting resistor is going to go across here. And then this has current, and this current can flow either in this direction or in this direction or both. And the way that we can control that is that we can, so in order to have this work, we'll have the value of this be either high or low. So if this is high, then current will flow through it in that direction. If this is low, then current will flow through it in that direction. And then depending on which of these that we energize, current can flow in the opposite direction. All right, and so what we see here on the back is that all of those diodes are connected to these rings, and these rings come back and then connect back to the MSP430. And so the idea is that in order to have one of these diodes turned on, we have to turn on this line, and then we have to turn on one of these 1, 2, 3, 4 separate lines. So there's 6 banks of 4 diodes, and each bank can be controlled by turning on the resistor, and each diode can be turned on by turning on the particular pin, right? And so now there's two ways that this can work, right? So this value can be high, and this value can be high, in which case no current will flow. This value can be high, and this value can be low. It can be ground, in which case current will flow through this direction. Or also, if we make this pin an input, then this value can be high, and then this diode is effectively not connected. And so that's our sort of our trick here. But okay, so in order to put your diodes on correctly, you need to have the proper direction of pins. Now, the arrow is drawn this way, right? So ideally you would line it up that way, right? So from anode to cathode, but you don't have to. In principle, you could also do it exactly the opposite for all of them, in which case the control would be reversed. But if you don't do it the same for each bank, right? So this LED and this LED are both being controlled by the same the same cathode pin. If you do it opposite for these two, then things won't work, right? So you really want to make sure that you know which direction your diodes are supposed to be pointing. All right, so how do you know when you look at a diode like this, which direction the current is supposed to be pointing? Well, on the back of it, you can see there's a little arrow that's drawn. That's helpful, but it's not that helpful because when you're soldering it, you got to put it down this way, right? So let me flip it over again. And what we see is that, okay, there is an arrow, it's going in that direction. And now to very carefully flip it over. Use tweezers if you're going to do this. Don't use your fingers. But you can see that there's a little bit of green on this side. So that tells you that that side is the cathode, the ground side. That's the negative side. But don't do it that way. That's not the right way to do it. The right way to do it is to use a multimeter. So here's a multimeter. And if you set the multimeter, onto the diode setting. So let's see, let's get into focus. All right, so focus. It beeps, there's voltage. Ooh. There we go, that's better. Now, where's the diode setting? So if you look for this right here, this symbol is the continuity or diode symbol. This is, I think most of the multimeters in the lab are Fluke multimeters. This is a no-name brand, but it'll work just as well. And so you can see right now it's a 0L. That says that there's nothing there, there's nothing connected. This is a useful setting if you're trying to find shorts. What you can do is you can connect both of the pins together. And then what you'll hear is beep. But we're going to use it actually to test our diode. So let's go back. So here's our diode. And what we'll see is that if we, sorry, I'm pushing the wrong button on my little camera here. If we hook the pins up to the diode in the wrong configuration, nothing happens. If we hook them up in the right configuration, so with black, which is connected to the common or the ground input, the black input on the multimeter, and red, which is connected to the positive one, the diode should light up and it should work. But okay, it doesn't because I haven't pushed the select button on this multimeter. So now if I push the select button, you can see that I switched between continuity and diode. So make sure that you're in diode mode. So now we'll go back to diode mode. We'll go back to what we believe to be the wrong configuration. So this is the wrong configuration. And we'll go to the right configuration. And again, nothing has happened. Awesome. Why is that? I love how demonstrations. Live demos never go according to plan. Maybe that diode is bad. Maybe that diode is an IR diode. Let's see this diode here. I know that these are on this breadboard are red. Maybe my no-name multimeter is actually no good. Let's see. That all seems fine. That all seems fine. Oh, something. Diode go. There's my diode. Let's just try pushing harder. Nothing. Well, all right. Let us pause the recording and come. All right. So hopefully that cut worked and we're back to being live again. I think that LED had something wrong with it. I don't know if it was broken or if it just wasn't any good. So here's two more examples. So this is what's called a side view LED. It's actually meant to be mounted sideways on the PCB, and you can see that on its bottom side, it has just a line that marks the cathode pin. So again, if we do this way, we don't see anything. If we put the pins this way, which is the proper way, so positive on the positive side and negative on the negative side, hopefully you can see that LED is lighting up. So similarly, this is a 1206 LED, which is the kind that you guys are going to be using. This particular model doesn't have anything on the back, which, you know, who knows? You don't really care about that anyway, because you're not putting it on the PCB in that direction. But you can see that there's a small line on this side that's not on this side. And so now if we line it up properly, then it lights up really nicely. So when you're placing these on the PCB, make sure that you figure out the proper orientation of your LED and then put it on properly. So I have another video that's going to show the process of actually taking this printed circuit board, lining up I'm trying to find, this is a stencil for solder. So we want to line up the stencil properly so that everything can be put on as it's supposed to be put on. And actually, it looks like this may be, I don't know which side is the top and which side is the bottom, but anyway, this will be in another video for you guys so that you can see how you're supposed to line it up. But the idea will be that you line everything up really nicely, and then you scrape some solder on top, and then you very carefully unpeel it like this, and then with tweezers you put all of your LEDs on the LED spots, and you put resistors on the resistor spots, and then you put it in the oven, and then you cook it, and everything melts, and then you end up with a beautiful functional printed circuit board that you then can proceed to do the rest of the lab with. So I'm looking forward to that. I'm looking forward to seeing you guys all tomorrow, and I hope you enjoy this brief video.